Welcome back to another tutorial. Today we're going to be setting up a yield monitoring system for a Case IH mid-range combine. So we're at the run screen now. We're going to navigate back to our toolbox. This is where the majority of our setup will be at. And the first thing we need to look at is the advanced interface level. We need to make sure that that is set to advanced, and that enables your data recording. So if it's set to basic, it acts as if the USB does not exist. Current vehicle, if we set that up, that allows us to know what vehicle that we're in. So there is two different software packages, one for flagship, one for mid-range, that we have to enable there. Toolbox operator, this allows us to use an operator for tracking purposes. It also allows us to use it for desktop software if we want to track the operator as well through the desktop software. Toolbox layout. We have a video dedicated to the run screen layouts, but if you would want to customize a run screen layout for different configurations across the board, you can certainly do that. Moving on down, we'll go into header. You may see head 1 or head 2. You may see just one header tab here, but they're pretty much all the same setup. The maximum working height, this is for each crop type, so we need to calibrate this per crop type. But what we would do in this case is we would go into here, we would use the multi-function handle and actually raise or lower the feeder house, and then we would calibrate at what value we want to stop the data recording for that particular crop. So if we're in corn and we switch over to beans, we do have to calibrate this differently. This is the point where all the data recording would actually stop. So we would raise or lower the feeder house, hit cal, hit enter, and then this value would change. Header width, this is the actual physical width of the header. So this is used for boundaries and obstacles as we're moving through the field. Your target working width would actually be your swath width that we would use for painting on the map. Width adjust step, if we use that, that is for manually adjusting the width of the header if we get into a situation where we would want to decrease the actual swath width. This would be if we had previously covered that area during harvest. Header center offset would be the center line of the header, and typically this is going to be set to 0, but if you for some reason have an offset head, you just measure from the center line of the head, measure the center line of the vehicle, and then find out what the difference is. And if it's offset towards the right, it would be a positive value. Offset towards the left, it would be a negative value. Auto cut width, this is, I would recommend turning this on at all times. You will have to use GPS to do this, but this automatically cuts down your head width based on previously covered areas, so it makes it a lot easier than having to manually adjust those values. Moved on down to head 2, you will have a header type, so this is going to be different if you have a platform header versus a row head, of course. Moving on down, if you wanted to set up cameras, you can certainly do that. So we have 3 camera inputs inside the display, and if you want to maybe use a camera on the unloading auger and one in the reverse of the combine, you can certainly do that. GPS, we can use autonomous. We are not limited to DGPS, so we can use autonomous if we want to, but if we're going to yield map, we certainly need to make sure that something is set up there. And then Toolbox PF, the season setup date, we need to make sure that that is set to the correct date. So at January 1st, 2018, all of the data archives inside the display, and the only way to retrieve it from that point, as far as your mapping, would be the desktop software. Toolbox yield, so this is just setting up the yield and moisture sensor. And then the yield flow delay, this is just a machine configuration or timing, I guess you would say. So it's the point at which the crop is cut to the point the crop hits the flow sensor. What is that time delay? And we use that for mapping purposes. So we need to make sure that wherever that crop is cut, when it hits the flow sensor, we need to assign that value to that particular GPS point. Nav S and Nav P, we just need to make sure that this is set up and we have an actual auto guidance system if we are using AccuGuide. Moving on down to performance and profile. So from here we need to make sure that we have a grower farm field selected, as well as a task and a crop type. So if we calibrate for corn, we need to make sure that corn is set up there, and then the task itself will be assigned one crop type and one crop type only. Moving on down to calibrations, so we will cover a distance, a moisture, and a yield calibration a little bit later on, but the main thing I want to go over is the crop calibration. So just like calibrating the crop for the feeder house, we need to make sure that we have the crop type selected here. The manual moisture is for a circumstance where the moisture sensor fails and you need some kind of value in there. You can override the system by putting an actual value there. Crop trade moisture, crop trade weight. These are generally accepted units for trade purposes. So generally this is going to be correct. If you have an elevator that is using something different, you can certainly override that, put something different in there. If you choose to import the cal values, this would import values from a similar crop. This is not recommended for a lot of the accuracy. And of course, if you had two combines, maybe two mid-ranges running side by side, even the calibration values may be different just because you got two different machines. So it's not recommended that you use this, but you do have that option. The C1 is a vibration constant or calibration. This can be changed if the system calibration or vibration is creating false yield readings by the machine vibration. So we can change this if we're having issues with the flow sensor. Your C values, these are shown as pounds per second multiplied by 100. Your M percentage is the moisture sensor offset, and this is calculated during the moisture calibration. Typically this is going to be -5 to 8%. M1 is the moisture sensor constant. This is a fixed value based on the crop type. And then lastly, S1 is the moisture sensor sensitivity, and this is also a fixed value based on the crop type. Like I said, we will go into detail on other calibrations in another video, but this is the basics of setting up a yield monitor for a Case IH mid-range combine. Thank you.